Now suppose we have 2, 4, 8, 16. What type of number pattern is this? Is it a linear or an arithmetic? Right, remember linear is also called arithmetic, let's not forget that. Or is it a quadratic or a geometric or a special one? Right, now remember, same procedure, right minus left. So we're just gonna say, what is 4 minus 2? It is 2, right? What is 8 minus 4? It is 4. And what is 16 minus 8? It is 8. Does it have a constant first difference? No, because these numbers are not the same, so it's not in linear or arithmetic. Then we go further. Okay, we say right minus left. What is 4 minus 2? It's 2. What is 8 minus 4? It is 4. Now, does it have a constant second difference? No, because those numbers are not the same, so it's not quadratic. So if it's not linear, it's not quadratic, is it a special or a geometric now? Because I said a special does not have a constant second difference or a constant first difference. But I also said for a special it does not have a constant ratio. Does this one have a constant ratio? How do we get a constant ratio? Okay, so for a constant ratio, to check whether a pattern has a constant ratio, you are gonna say, remember I was saying right minus left, right? You're still gonna do the same thing, right minus left. However, yeah, you're gonna do that, but just remember one thing. This is in the first position, this is in the second position, this is in the third position, this is in the fourth position. So this is what you do. You're gonna say T, this one, right over left, right? So you're gonna say the second one over the first one. So you're gonna say 4 over 2. What is 4 divided by 2? It's 2. Then you're gonna say right over left, okay, when you want ratio. So you're gonna say T3 divided by T2, which means 8 all over 4, right? It gives you 2. Then it means this number, if it is the same as this one, it means it is a constant ratio. We call it ratio if we have multiplied or we have divided. Okay, well, okay, mostly it's if when we have divided, but well, it just means, what does it mean? What does a constant ratio actually mean? It means we don't do this to move from one term to another. Instead, this is what we do. To move from this to that, we actually, instead of saying we add 2 or we minus 2, we multiply by 2. What is 2 times 2? It's 4. We multiply by 2. What is 4 times 2? It's 8. We multiply by 2. What is 8 times 2? Is 16. So that is what a constant ratio says. So a constant ratio deals with division or multiplication, right? Because to get it, what do? We divide. But when you put it into the sequence, right, we are multiplying to get to the next term. I need you to understand that to get the ratio we divide, but when you put it in the sequence, to move from one term to another term, we are multiplying by that ratio. Okay, so that's why it works with division and multiplication. Now, if it has a constant ratio, then definitely it is a geometric. Now, how do we get the general term for a geometric? Well, to get the general term for a geometric, it is not difficult. This is what we do. We're gonna say Tn is equals to A times R, and then you say exponent n minus 1, or to the power of n minus 1. You can even put them in brackets, okay? So let's just try to write it nicely. So we say R here, then we say exponent n minus 1. So we need to find what is the value of A, what is the value of R. Only two things, A and R. What is A? Do you remember that I said for grade 12, we call them arithmetic, and now remember for grade 12, instead of saying well, let me just go back to arithmetic a bit. Remember, to find the general term for an arithmetic for grade 12, you use Tn equals to a plus n minus 1, sorry, n minus 1d, right? Right, yes, n minus 1d. We said, what is a in that? We said a, it is the first term. So even here, a is the first term. What is our first term here? Yes, it is 2. So it means we already know that a is equals to 2. Wow, we're only left with r. What is r? R, it is the constant ratio. R is the constant what? Ratio. Didn't we find the constant ratio? Yes, we did. We found it to be 2. Therefore, our r is equals to 2. Therefore, Tn is equals to 2 times 2 to the power of n minus 1. That's it. You have the general term for the geometric sequence. You see, it's very much easy. Now you can even test it. Let's see. The first term is 2. If I substitute the position here, instead of writing n, I write 1. I should get my answer as 2, because remember, we said these indicate position, and we said position is n. So if I say T1, I must say 2 times 2 into 1 minus 1. The answer I must get here must be 2, because T1 is 2. The first term is 2. If I say T2, what is the answer that I must get? 4. But I'm going to substitute 2 because 2 is the position, okay? It is in the second position. So you're going to say 2 times 2 into 2 minus 1. Instead of writing n, you write 2 because that is the second position. And when you put it in your calculator, 2 minus 1 is 1. So 2 to the power of 1 is 2. 2 times 2 is what? It's 4. You can even check what is the fourth term. 4 minus 1. You're going to get that it is 16. So this is the correct general term for that geometric sequence. Then with that, you are fine with finding the general term. The next phase of number pattern videos that we're going to have, it's dealing with some previous question papers, so that we understand how to answer questions more. Okay, so I hope that you understand, and remember, if you do not understand or want extra assistance, just send me an email. My email will be in the description box. Send me an email, and then we can further arrange how we can explain further. Thank you so much for watching. Don't forget to catch the next ones.